pleasant day to all. Today, we will discuss the first law of thermodynamics and how it works or is related to ecology. And here are the significant ideas for the first law of thermodynamics. First, the law of governing energy flow. Second, the law of conservation. And third, the principle of conservation of energy.
The law of governing energy. The first law of thermodynamics deals with the conservation of matter and energy. An energy state that cannot be created or destroyed but can only change from one to form to another. For example, the energy of visible light is absorbed by the green plants through photosynthesis. It is changed into a chemical energy stored into the glucose of molecules. Because all living organisms, including plants, consume glucose in respiration and use the stored chemical energy for their metabolic activity. Some of energy is dissipated as heat, that is another form of energy. The term energy is quite familiar to us, and we use it in a very general of our sense. Often, this usage does not correspond to the precise scientific definition. Therefore, the important is define it precisely. The energy is defined as the capacity to do work. We use energy to cook food. We need energy to raise our feet. A truck climbs uphill when the energy is supplied to it, from combustion of diesel oil, and the light bulbs glows when the electric energy is supplied to it. The developing countries of the third world face perpetual energy is shortage. And in the present day world, energy and prosperity go hand in hand. Such as the sun is the ultimate source of our energy, which caters to the needs of our ecosystems. In the interior of the suns, the thermonuclear reaction is continuously going on at a temperature about 108 Kelvin, wherein hydrogen is converted into helium. This is accompanied by the release of a huge amount of energy which manifests itself as heat and light. Energy captured by the autotrophs will never revert back to the sun. Similarly, the energy which passes to the herbivore does not revert back to the autotrophs and so on. Thus, the flow of solar energy is unidirectional. Its immediate implication that an ecosystem will collapse if the sun stopped giving out energy. The second important fact is that its trophic level of energy content decreases progressively. This factor is easily explained by noting that the trapped solar energy is used up in a metabolic activity and measured as respiration. In an ecosystem, energy is transferred in an orderly sequence. We explained above that energy is always unidirectional. In a chain of events, some useful of energy may be lost as heat. Two descriptive physical laws apply to such a situation.
First law of thermodynamics, potential and kinetic energy, how it's related to first law of thermodynamics. In the same way that potential energy can be converted to kinetic energy, while conserving the total energy of the system, the internal energy of a thermodynamic system can be converted to either kinetic or potential energy. Like potential energy, the internal energy can be stored in the system. First law of thermodynamics relates the various forms of kinetic and potential energy in a system to the work which a system can be performed and to the transfer of heat. Maaari itong maging sinag ng araw pati na rin ang mga sinag na ibinubuga ng mainit na katawan sa paligid natin. Potential energy states that energy can neither be created nor destroyed, only altered in form. This produces a change of stored energy within the control volume. Kinetic energy that an object possesses when it moves converted to heat energy. That the first law of thermodynamics.
The first law of thermodynamics is a thermodynamically appropriate version of the law of energy conservation. Another frequent expression is that energy can neither be created nor destroyed, which states that the overall energy in a system remains constant, but it may be transformed from one form to another. In a closed system, this is the core idea of the first law, while there are many nuances and ramifications that may be better expressed in more intricate forms. For a system with a constant amount of matter, it distinguishes between two types of energy transfer, namely heat and thermodynamic work. The law of conservation of energy of any isolated system which cannot exchange energy or matter is constant. The internal energy of a system is also defined by the law as an extensive property for accounting for the balance of energies in the system. It is possible to change the shape of energy, but it cannot be created or destroyed. In addition, naturally matter and energy can be transformed into one another without breaking the first law, according to mass energy equivalence.
The first law of thermodynamics, also known as the law of conservation of energy. It states that the energy cannot be created nor destroyed, but it can change from one form to another. So while this energy remains constant, its form can change. But not only does this form changes, but also it applies to its quality or its value. So this value means the ability to do work. This view allows us to compare and evaluate different forms of energy between one and another. According to Bill 127, radiation and electronic energy are example of form of energy with highest um, value form or has the highest capacity to do work, while the heat is an example of form with the smallest energetic quality or value, and which may be considered as the almost or the final state of energy degradation, and so thus considered a high form of entropy. Heat is always transformed in one direction only, from high quality like radiation to a sequentially lower quality, ending up as its lowest form like heat, and it ends up as a dissipated energy as a result of a reversibility of process.
The principle of conservation of energy applies to ecosystems that are subject to the energy conservation concept as well. Energy is a form of food moves from one organism to another in an ecosystem. When an organism is devoured as food, the energy that was not used by the organism is passed on another organism. The energy that has absorbed by the organism as food is used for growth, reproduction, and other processes. According to the law of conservation of energy, this energy flow along the food chain ensure that the overall amount of energy in the ecosystem stays constant. However, as the food chain progresses up through the ecosystem, the amount of energy available to the creatures and each level drops. This is because some energy is wasted as heat and other types of waste throughout the transfer process. A key aspect in determining the stability and diversity of an ecosystem is the amount of energy available to the species at each trophic level. A problem with the ecosystem's energy cycle, for example, due to the introduction of a new species, can have a significant impact on the other species in the ecosystem and potentially lead to changes in the ecosystem structure and functions.
The term exothermic was first coined in 19th century by the French chemist Marcelin Berthelot. So in thermodynamics, exothermic reaction occurs when the temperature of a system increases due to the evolution of heat, and this heat released into the surroundings. And it may affect the environment by the resulting of an overall negative quantity or a damage because of the reaction of the heat that is releasing into the surroundings. The examples of exothermic reaction is combustion reaction, neutralization reaction, and respiration. And even burning of a candle and the reaction of a strong acid with water are also examples of exothermic. But combustion of methane is the most exothermic because of the huge amount of heat is involved of this, and it may cause damage by the surroundings. It is also have a chemical that releases heat and has a negative standards of enthalpy change. Enthalpy means it is also a property of thermodynamic system. It is a sum of the system in which the internal energy and a product of its pressure and volume. It is a state function that used in many measurements in chemical, biological, and physical constant pressure, which is conveniently provided by the large ambient atmosphere. The first law of thermodynamics states that the energy cannot be destroyed or it is created, but it can be being, but the energy is being just transferred.
Good day everyone, this is my report about endothermic process. So what is endothermic? Endothermic reactions are processes in which heat is absorbed from the surroundings. This absorption of heat causes the temperature of the system to decrease, which can be seen by a negative change in the enthalpy or energy content of the system. The absorbed heat energy is used to break bonds within the reactants, making them more reactive and allowing them to form a new bond and become the products of the reactions. In other words, the heat energy is used to fuel the reaction, making it possible for it to occur. Also, the endothermic reactions are common in biological systems and have a wide range of applications. In the biological systems, endothermic reactions plays an important role in regulating body temperature and maintaining homeostasis. Like for example, sweating is an endothermic reaction that helps to cool the body by absorbing heat from the skin. Similarly, plants use two endothermic reactions to absorb light energy and convert it into chemical energy through the process of photosynthesis. Overall, endothermic reactions are important for many processes in both the natural and human-made world, making them a key of area of studies in many fields of science.
Endothermic is a term used to describe a reaction or process where heat is carried from the environment into a system.
So during kaning nga process, if energy kay ginakuha or taken from the surroundings, ang temperature sa palibot niya will decrease. One example is melting ice cubes. As the name implies, the term endothermic, endo means absorb, thermic means heat. So the first example of endothermic reaction is the melting of ice, di ba? The illustration indicates that endothermic reaction cause their surroundings to get colder. Also one example is photosynthesis, which is also a endothermic reaction. That this means that kanang if there is no energy from the sun, dili mabuang photosynthesis, so it is an endothermic reaction. Photosynthesis kay require siya og light energy to react carbon dioxide and water to produce glucose and oxygen. Ang gatawag ato nga ga-produce og glucose and oxygen is ay ang ga absorb sa light energy is the chlorophyll. Third example is the evaporation. Okay. Evaporation is a process which liquid molecules change into the gaseous phase. This phase transition requires the absorption of energy. Hence, evaporation is an endothermic process.
Good day, everyone. I am explaining you the topic about endothermic. Endothermic animals such as mammals and birds generate heat internationally through metabolic process, allowing them to maintain a stable body temperature. So kinahanglan nila og stable body temperature nga dapat mo allow gid sila sa mga mammals, sa mga other animals nga dapat nara sila sa gawas sa kwan. Dapat stable good despite changes in their environment. So kanang ilis-ilis og environment, no. So nang galahi-lahi og environment, for example is kung naka sa initan, dira lang ka sa initan, pero pwede ka pun kamo palandong for despite changes of their environment. So this is a crucial for survival with extreme temperature. So pinakainit nga mga temperature, example mga extreme high temperature like heat, no. Kaya kung mag-init, di na gid natin na kaya mo putag lipong ana, di ba? So such as polar region. So kana sa polar region is tugnaw na diha nga region, and then murag gamay ra mga survive nga mga animals that allows endothermic animals to be active during period of low and such as night. So kada sa mga gabi kada pwede na sila mga arang-arang mga gabi na. So next is endothermic reaction also plays a role in energy conservation within ecosystem. This is for the example of mga herbivores such as cows and deer. Mga use of endothermic reactions to digest to plant or material, releasing the energy stored in their cellulose. So mao na sila mga dapat mga kinahanglan nga dapat kinahanglan ginila og energy kay naabot sila sa init. So next is this energy can be used to fuel their activities support with their growth. No, kinahanglan nila og fuel nga kanang like mga pagkaon nila kay para maka survive sila sa in their growth, no. So and then eventually enters the food web as pass to the organism through predation. So next, in addition, endothermic reactions can also be controlled temperature in ecosystem and preventing overheating. This is for example of transpiration of water from leaves. Nagikan sa ulan, paingon sa tubig ay sa dahon. Then dira mag-inom ang uban nga mga exotic mga animals like mga ants or any kind of animals nga pwede mo kaon ato nga plants. So plants can help to cool the surroundings of environment. So ang mga tanom pwede gid na sila makatabang sa mga surroundings sa mga environment kay they can manage to control our environment nga pwede nila mapabugnaw. So next is this helping to maintain the overall temperature, so balance in the ecosystem. So mabalance gid nila nga ang init o ang kabugnaw sa mga temperature. Then overall endothermic reactions can play a critical role of maintaining stability and promoting growth and survival with the ecosystem. So pwede gid nila makuan sa tawon ma-survive, sustainability gid na nila nga ma-promote ang growth and survival, no, kay para makasurvive ang mga hayop within this kwan within the kwan mga like sa mga nasa mga gawas. Then plants also can help the others, no, maka lahutay maka unsa tawon ni mga maka cool kay kung walay mga tanom kita diri wala tay baton ug maunsa na ta diri, no, that's what I'll take it.
To understand more, let's have some quick video presentation.
Welcome to Mumu Math and Science. In this video, I'd like to talk about energy flow in an ecosystem. All living things, which are biotic factors, require energy. Some of these biotic factors get their energy from the sun. Others eat other biotic factors. As a result, energy flows in ecosystems. This flow of energy can be represented with food chains and food webs. For most ecosystems, the ultimate source of energy is the sun. And as you move from one organism to another, you move up a trophic level. For example, moving from the mollusk to the white perch would be a trophic level. Producers use photosynthesis to create their energy, and they are a very large source of energy in most ecosystems. Plants and algae are examples. As consumers eat these producers, carbon bonds are broken and energy is released, and this energy is transferred from one level to another. However, as you move from one trophic level to another, you lose 90% of this energy. This is known as the 10% rule. For example, if you start with 1,000 joules of grass and a grasshopper eats the plant, only 10 joules will be transferred. And a bird eats the insect, only 1 joule will be transferred. Where does this energy go? Most of the energy is lost as heat. The energy flow in an ecosystem follows the laws of thermodynamics. The first law states that energy cannot be created nor destroyed in a system, however it can be converted from one form to another. The second law states that this energy conversion is never completely efficient, and as a result, most of your energy is lost as heat. So there we go, the energy flow in an ecosystem. Thanks for watching, and Mumu Math uploads a new math and science video every day. Please subscribe and share.
In conclusion, ecosystem can benefit from applying the first law of thermodynamics. Although energy in ecosystem is continually changing forms, the overall amount of energy in the system is constant. In the case of the sun, energy is provided in the form of heat and light, which is subsequently absorbed by plants through photosynthesis. Following that, the plant provide food for herbivores, which in turn feed carnivores. Through this food chain, energy is passed from one organism to another, yet the ecosystem overall energy balance remains stable. The first law of thermodynamics aid in our comprehension of how energy moves through the ecosystem and how it's altered.